My name is John Huntsman, and I will be introducing you to my paper titled Melanin Leading to Vellus Hairs Gave Advantage to Ancient Hunters. In my paper, I analyzed several different theories for why humans became hairless. Specifically, my hypothesis stated that this appearance was caused by a need to cool themselves while long-distance running and the formation of vellus hairs due to the increased melanin in the skin. The first theory I examine is that humans went through an aquatic period in their evolutionary history. This theory is based upon examination of aquatic mammals such as whales and dolphins. These mammals made the transition from terrestrial to aquatic environment as witnessed by their vestibular limbs and lack of gills. Hair is of no advantage in the water and would be lost, like in the case of dolphins. Other evidences of this theory include humans being able to control their breathing underwater, the similarity of dolphin and human brains, location of subcutaneous fat, and human bipedalism being similar to penguins, an aquatic bird. Detractors of this theory point out that other animals, such as dogs, can control their breathing underwater, that humans' subcutaneous fat more closely resembles primates than aquatic mammals, and that other terrestrial species are bipedal, such as kangaroos. The next theory I examine is that hairlessness came first before bipedalism. This would have required a hairless mutation to have spread through a population. As mothers became hairless, their young would have no longer be able to cling to their hair, as is the case in other primates. This would have forced the mother to hold the infant in her upper arms. This in turn would have forced her to walk bipedally. As she carried the infant in her arms, she would have required more help from the father of the young, and so that he could ensure his offspring survived. This would have created a stronger bond among the mating couples. Since the mother could hold the infants in her arms, this led to less mature infants surviving after birth. This made it possible for infants with larger brain sizes, but smaller and less mature, to be born and survive. Later, this larger brain capacity could be selected for through sexual selection. The trouble with this theory is that the consensus among nearly all scientists is that bipedalism preceded hairlessness. Sexual and parental preference is another cause given for why humans became hairless. Hairlessness would have began with a mutation which caused part of the population to become less hairy. If that relative hairlessness became preferential in both mates and children, it could have been perpetuated generation after generation. The individuals with less hair would have mated at a higher rate, and offspring with less hair would be less likely to be victims of infanticide, leading to a greater decrease in hair. If subpopulations were created, they could have created a culture of us versus them mentality, further isolating the populations. However, it is unlikely their current brain capacity allowed for complex culture to be established. As well, it seems unlikely a trait such as losing all of the body hair could be perpetuated so completely without some advantage to survival. Another theory is that of photobiomodulation. To understand this theory, we must examine the electron transport chain. The electron transport chain creates energy, ATP, as electrons flow from areas of high concentration to low concentration. Under photobiomodulation, these electrons would be excited by photons and move more quickly, accelerating the production of ATP. This would have given these early hominids access to more energy, leading them to be better hunters and having the capacity to increase their brain size. The drawbacks of this theory is there's very little evidence to support it, besides a few studies done by manufacturers. Some have claimed that hominids could have become hairless as early as Australopithecus. We need to examine both the elevation at which they lived and their daily activity to examine this claim. The sites which these hominids lived has dropped in elevation from a couple hundred feet up to 1,000 feet. This means that the environment in which they lived was much cooler than previous studies have examined. They would have required less heat dissipation during the day and would have needed to retain more heat at night. The previous studies also overestimated daily activity at them being active 100% of the day. Most primates are active for less than 17% of the day, meaning that there was much less heat that needed to be dissipated than previously thought. These heat load factors would have given Australopithecus little advantage to being hairless. Hairlessness among hominids likely arose in Homo erectus due to persistence hunting. Their goal during persistence hunting would be to drive their prey to hypothermia in order to capture larger prey than would be possible otherwise. In order for Homo erectus to maintain their own body temperature, they would have needed to effectively dissipate body heat. This would have required hairless bodies with effective sweat glands. Other anatomical adaptations which appeared at this time support this hypothesis. They include enlarged gluteus maximus, narrow waist, and the thorax becoming more mobile, all of which would have increased their ability to run long distances. Instead of becoming more hairless, it is possible that the type of hair simply changed. Instead of thicker and longer terminal hairs, thinner and shorter vellus hairs developed over much of the body. This is supported by humans having the same hair follicle density as chimpanzees, but less hair thickness. This development could have developed due to increased melanin in the skin due to increased sun exposure as hominids moved into the plains. As melanin increased and vellus hairs increased as well, it would have provided the lack of hair necessary for persistence hunting. Studies have shown that lower follicle density and shorter hair correlate with darker skin pigmentation. This theory that skin pigmentation developed before hairlessness is further strengthened by the reasoning that if hairlessness were to develop first, then all humans, regardless of skin pigmentation, would have been equally as hairless. This follows my conclusion in the paper that humans didn't lose density of hair follicles, but just density of hair, which made it possible for Homo erectus to persistent hunt.